So welcome to my new video about differentiation. In the previous video we have learned about limit, uh, the concept of limit, which is an absolute necessary for the to elaborate about differentiation. So what is differentiation? So first of all we have to know uh, we have to know that in a function fx, in a function fx, this is a function of x, function of x, function of x, where x is the independent variable. That means we can change the value of x as per our wish, and according to the change of value of x, the function of f the function fx will take its value. We can define the function fx with a new variable y, or whatever the notation we want to declare it. So y is the new variable, which is the dependent variable, because the value of y depends on x, depends on x. So x is the independent variable, y is the dependent variable. Y is equal to fx. This x means x is the function of x, that is y takes value when y takes value according to the value we put in x, and y also changes its value when we change the value of x. So let us we define the change of value of x is denoted by del x. This is the Greek letter del. So del x is the change in x, and accordingly the change in y can be denoted by del y. This change can be of any value. It can be infinitesimally small value, it can be infinitely large value. But in the case of differentiation, this del x, how we define? Del x has to be approaching 0. That means limit del x has to be approaching 0. And accordingly, limit del y has to be approaching 0. So we have to take the change in x, a very small value, that will be infinitesimally small value, which is not is equal to 0 but is tending to 0. Similar for del y also, that will take a infinitesimally small change in y for the infinitesimally small change in x, and which is not is equal to 0 but is tending to 0. So differentiation of y, or the derivative of y with respect to x, will be denoted by is denoted by actually in general d of y with respect to dx. So derivative or differentiation, the same thing, derivative of y with respect to x is denoted by dy dx, or f dash x. This is the first order derivative, or y dash, as y is fx, or y dot. This one dot or one dash means the first order derivative. This is actually d dx of y. This d and y is not in multiplication with each other, or d or this d and x is not in multiplication with each other. This is just a sign to denote the change in x, which is infinitesimally small. That is, this thing is equal to dx. Sorry, del x would be here. When the change in x is infinitesimally small, infinitesimally small, let me change a different color, this is small, that is denoted by dx. This is the whole, this d and x is not in multiplication. I am repeating again. This is just a sign to denote that the change in x is infinitesimally small. Similarly for dy also, del y is equal to dy, so we have just discussed about the derivative or differentiation of y with respect to x, which is denoted by d dx of y. This bracket, we can give bracket or not, whatever we want, which is also denoted by this and this. Okay, now so we can say that the derivative of y with respect to x is limit, let me write it down for a clear understanding, differentiation of y. We can take any variable which is dependent on x, or any variable which has or a function is a actually a the function is a dependent variable of the argument variable of the function. This is the argument variable. Okay, here argument we have put as x, and this function variable is denoted by y, suppose. So differentiation of y with respect to x is limit del x tends to 0, del y will also tends to 0, as we have discussed, del x del y, sorry, del y del x. We can obviously find del x del y. That would be differentiation of x with respect to y, obviously, and that would be just 1 by del y del x, nothing else. So this is the differentiation of y with respect to x. This limit is absolutely necessary. Without this limit, del y can take any value, del x can take any value. So del y and del x are not themselves denoting that they are taking infinitesimally small values, but dy means that the change in y is very small, and dx means the change in x is very small, but not del y means the same. Del y means obviously the change in y, but it can take any value, 0 1 2 3 4, any value, not only integer, any real value. We are talking about in the real space here. So this is the differentiation of y with respect to x, this is the notation which is denoted by dy dx. Now before we solve any problems, there is the first thing that we can differentiate. Say a function of x is x to the power n. We can write this function of x as y. The formula for this is dy dx. If we differentiate y with respect to x, would be n x to the power n minus 1. Now how is it coming? How is it coming? How is it coming? Proof for this would be very easy. Okay, first of all, just for a recap, which I have not taught in any of the videos, obviously. For a binomial expansion theorem, for for this kind of expression is nc0 x to the power n y0 plus nc1 x to the power n minus 1 y to the power 1 dot dot dot. The nth term will be ncn x to the power 0 y to the power n. We will be needing that to prove this one. Okay, just for that I am just using that. The proof of this one we can say like, so dy dx would be, so what is here, so we can write that del y is equal to would be f of x plus del x minus f of x, because this is y and this, right, like this, because fx is y and this is obviously y plus del y. So y plus del y minus y would be del y. So let me, okay, just leave it like that. Okay, so del y is this, and sorry, and del x, sorry for the disturbance, and del x would be there obviously. Now dy dx is equal to would be limit del x tends to 0 del y tends to 0, and let me write again del y del x, and what we have got as del y is that with the limit, we in each and every step we have to write down the limit, because without limit del y is not dy, or without this limit del x would not be as same as dx, as we have just discussed here and here also. So dy dx would be f of x plus del x minus f of x divided by del x, where del x tends to 0 and del y also tends to 0. Okay, so here fx is x to the power n. Now we can write limit del x tends to 0 del y tends to 0. If we put x plus del x in place of x in this function, we can put any value of x. So we are putting x plus del x as in this argument. So that would be x plus del x to the power n, x plus del x to the power n minus fx is only x to the power n divided by del x. So what is this? Limit would be there always. So by binomial expansion we can write that, let me write it below. binomial expansion we can write, is a different color. Binomial expansion we can write in C0 x to the power n del x to the power 0 plus in C1 x to the power n minus 1 in C1 x to the power minus 1 del x and dot dot dot, there would be the last term of this binomial expression would be n cn x to the power 0 multiplied by del x to the power n. This expression is for this one, so I am putting it in a second bracket, and this remains as minus x to the power n. The next step would be, this is a very easy proof. It is not as tough as it looks like. So this would be just xn. nc0 is 1, this is 1, so this would be just xn plus this is n, this is x to the power n minus 1, and this is just del x, so we will write it as it is, x to the power n minus 1 del x plus all the terms here which will be containing this del x with increasing power, as it is increasing from 0 1 2 3 the power, and the last term would be taking the nth power of del x. So the last term would be ncn is 1, this is 1, and this is only del x to the power n, and this is x to the power n minus 1, x to the power n divided by del x. So we can see that these two cancel each other, and all the term here, if we put del x as 0, would be, so we can actually say that all the term here, if put as del x is equal to 0, because del x is tending to 0, so we can put if we see the concept of limit, we can put as del x is equal to 0. So we don't need del y actually here, because del y was here and we have put it in terms of del x. So this would be come out, del x is come out, and limit del x tends to, so I'm writing it again. This would be okay for this term. Okay, let me clear it out and write it again. For this term we can write that this del x and del x will cancel each other. Okay, so this term we just singles it out, this term we will just singles it out. After that we cannot cancel with each of the term with del x, because these terms will be containing del x square, del x cube, and so on. So all the term will contain del x square plus all that, and obviously with the term of x also, the term of a, there will be term of x, del x cube plus dot 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 del x to the power n. These two have already cancelled each other out, del x. So the del x can be cancelled by just taking a common of del x. Each term of del x will just the degree will just go one down, so it will be 1, it will be 2, it will be n minus 1. So ultimately, sorry, there will be no suffix, I'm so sorry, x to the power n minus 1. So as del x tends to 0, this will go out. We can put 0 in in all the components, as there are del x in all the components. So this will be just okay, sorry, this is plus, I'm sorry, I'm just getting a brain fade here, nothing else, because because this is just this is in addition with all the terms. So this thing will come or singles it out with an addition, and all the terms would be 0 plus 0 plus 0 and so on. So ultimately, or the only remaining term would be this. So I will just complete it in this slide only. So dy dx when y is equal to x to the power n, already given, dy dx would be x to the power n minus 1. In the next videos, we will try to prove some another terms of another functions of x, like some exponential functions of x. And so for this video, this is the introductory part of derivative or differentiation, and this is the first thing that we notice in a calculus chapter, and this has been proven here. So this is the end. If you have any question regarding this video, you can always ask me in the comment section, and if you think that this video has helped you, you can like and share with others also, and please subscribe to my channel. Thank you.